In these examples, you're going to look at how we can use the first derivative to find and classify any stationary points. For example, the maximum or the minimum points. So the first step is to determine the derivative. So step one, we need to determine the derivative. And this is specifically the first derivative. Okay, so the first derivative is, and we had already calculated this previously, it's 6x squared minus 6x minus 12. And then step two is to find the critical points. And these are the points where f dash x is equals to 0. Okay? Where f dash x is equals to 0. And we had calculated this previously again in the previous videos. This was x is equals to -1 and x is equals to 2. Okay? These were calculated in previous video. Step 3 is to draw a sign diagram evaluating the derivative between or on either side of the critical points. So step 3 evaluates derivative between or on either side of the critical point. Okay, so which means we need to go ahead and draw a sign diagram. And we had already done this previously. And these are the x values, by the way, of the critical points. And we had -1 and 2. And what we did was we went further and investigated the signs of the first derivative. Now we picked some test points in between, and we said if you pick -2, we ended up with 24. If you pick 0, we ended up with 12. If you pick 3, you ended up with 24. And we said, well, the signs of the first derivative here it's positive, here it's negative, and here it's positive. Okay, what next? So once we have the sign diagram, the step 4, which is now important in this case, is to test the critical points for maximum and minimum, okay? The local maximum and minimum. So test the critical points for local maximum and minimum points. Okay, so we know that at x is equals to -1, if you look at the diagram above, we can see that the sign of f dash x, okay, the sign of f dash x changes from positive to negative, which means ideally this will look something like this. Okay, positive to negative, which means that's a maximum point. So you can say at x is equals to -1, f dash x changes changes from positive to negative So this is a maximum point. Okay. How about at x is equal to 2? We can see that here we are going downhill and then uphill. Okay. Which means that should be a minimum point. So at x is equal to 2, f dash x changes from negative to positive, which means this is a minimum point. Okay, so we have identified the maximum and minimum. So what will be step 5? Step 5 is to find the y values. So we need to find the y coordinates. Find y coordinates of the points. So the y coordinates, which means the y values, so we need to find f of -1. So you plug -1 in the original function, okay? And f -1 will be 7, which means that -1, 7 is the maximum point, okay? And we need to do the same for the minimum point as well, which means we plug f of 2, because that was the other critical point. So if you plug f of 2 in the original function, you'll end up with -20, which means that 2, -20 is the minimum point.